Today we're looking at section 5.7, which is on analyzing graphs of quadratic functions. We've gone through different ways to solve quadratics. We've looked at 4 different ways. We've looked at graphing, we've looked at factoring, we've looked at completing the square, and now finally we finished up with looking at the quadratic formula. So now we're going to go back to the graphs, and we're going to look at analyzing them and how else we can graph them using a different form called vertex form. So let's go ahead and jump right into that vertex form. So the vertex form is y equals a times x minus h, so quantity squared plus k. Where here, when they give it to us, they're giving it to us, so the vertex is given in the equation. So as we look at this, that h and k value is the coordinate of the vertex of the parabola. So the h is telling you how far it shifted left and right, gives you the x coordinate, and k gives you the y coordinate, essentially is what that's coming down to. And a determines, again, whether it will open up or open down. If a is positive, it will open up. If a is negative, it will open down. It also determines how wide or narrow, but that's not as important. So as we look at some of these things, we're going to look at identifying the vertex and how we can rewrite it into vertex form. So let's start with this first one. When it says analyze, they just want us to identify some things. So we know we're going to have a vertex. Now be careful here. The standard form of the equation. Notice that this is minus. So when this is a plus, that really means negative. It's the opposite sign. Because if it starts negative and now it's plus, that means we had to have put in a negative form for that. So the value here is going to be a negative 2. This one stays because it was positive, so it stays a positive 1. So our vertex is at negative 2, positive 1. So when I come back here, here's where my vertex occurs. Now my a value is 1. It's positive, so that means this is going to open up. Which means this is a minimum. So it asks us to draw the graph. So because we know this is the vertex, we also know the axis of symmetry goes through that. So if I just find 2 points here, if I plug in, we'll say negative 1 and 0. Negative 1. Negative 1 plus 2 is a positive 1. Squared is 1, plus 1 is 2. 0. 0 plus 2 is 2, squared is 4, plus 1 is 5. So I have negative 1, 2, and I have 0, 5. I can mirror image those to get the other half of the parabola, and I can draw my graph. Notice this has no solutions, so this would have had complex solutions if we were looking for the answers. And that's all there's to it. Once it's in vertex form, the graphing of it is actually a whole lot simpler than it was at the beginning of the chapter. So as we continue on, let's look at another example. Again, I'm going to leave the original format up there to remind ourselves of that. So the vertex, because it's negative here, it stays, we're actually taking the positive. This is negative, so it is negative. So our vertex is at 3, negative 2. Now a again is equal to 1. So because it's positive, that means it opens up, which means this is again a minimum. So when I plot that, we have 1, 2, 3, negative 2. And it's opening upward, so I will have solutions for this one. So again, we can just pick points on either side of it, it doesn't really matter. I'm going to go with 3 and 2, I'm going to go downwards. Or excuse me, 2 and 1. We already have 3. So 2. 2 minus 3 is a negative 1, squared is positive 1, minus 2 is a negative 1. And then 1 minus 3 is negative 2, squared is positive 4, minus 2 is 2. So So we have 2, negative 1, and 1, 2. And then again, I can mirror image those across my axis of symmetry. And that's the graph of my parabola. So you start by identifying your vertex. That would be step number 1. Step number 2 is to find out what is that A value. Is it opening up or is it opening down? And then step number 3 would be to just find 2 additional points that you can actually graph it. And then step 4 would actually be the graph. Alright, now they're giving us equations in standard form that we've been dealing with, and they want us to rewrite them in vertex form. So this is where this lesson can be a little tricky, especially if you didn't like completing the square. What we want to do, the first thing you want to do is make sure A is 1. If it's 1, we're good to go. I'm going to separate a squared plus 8x, leave some space, and then I'm going to leave the negative 5 on the outside. Just like with completing the square, we separate it with the constants and the variables. We're doing the same thing here. We separate it with the constants and the variables. It stays on the same side, I'm just kind of closing it in. Now I complete the square on the inside. 8 divided by 2 is 4, square 4, and I get 16. So I add 16. However, I can't just change the value of the equation and make that 16. If I added 16, I have to subtract 16. So really we're adding 0, but this allows me now to rewrite it so that I can factor it. So when I come down here, we have y is equal to, when I factor this, it's x plus 4. I pull that value down just like I did when we were completing the square, combine like terms out here, and it's vertex form. So when we analyze it, the vertex is at negative 4, negative 21. The A value is 1, so it opens up. And you could say this as a shift to the left of negative 4 and a shift down of 21. I'm not really worried about that as long as you have the correct vertex. So the important part to remember is that when you complete the square, you add it to the inside of the parentheses, and then you subtract it from the outside. So let's try this one. Now, with this one, when I separate this, we have negative 3x squared plus 6x, leave some space, minus 1. A is no longer equal to 1. So what do I have to do? I have to factor out between these. I'm ignoring this for a second. It's outside of the group. It's the outcast. We're leaving it out. I'm factoring here. So I have y is equal to, I pull a negative 3 out from just these two. We're left with x squared minus 2x, because negative 3 times negative 2 is a positive 6. Leave some space, minus 1. Nothing happens here, because this negative 3 will get distributed. This one stays the same. Complete the square. Negative 2 over 2 is a negative 1. When I square that, we get 1. So I add 1. However, when I look at this is distributing to the 1. So I've really subtracted 3. Because I have negative 3 times a positive 1. When I redistribute that 3, everything in there is multiplied by negative 3. So when I completed the square here, I've changed that. So it's no longer a 1, it's a negative 3, even though I didn't write it that way. So now out here, since I subtracted 3, I have to add 3. So you want to make sure if there's a value out front, you have to multiply that by this, and then do the opposite out here. So now we factor. We have y is equal to negative 3 times x minus 1, the quantity squared. Remember, this value just comes down, plus 2. So then our vertex is at positive 1, 2. A is negative this time, so it opens down. Alright, let's do it a couple more times so you guys can see some more examples of it. Okay, so for the first one, again, our a value is 1, so we're going to be okay. So when I separate this, we're going to have x squared plus 4x, leave some space, plus 6. Complete the square. 4 over 2 is 2. Square it, 4. So I add 4 here. Because I added 4 on the inside, I have to do the opposite so that it equals 0. So I subtract 4 there. So I'm going to bring this down. When I factor this, again remember, this factors with this piece. So it's x plus 2 squared plus 2. So what's my vertex? The vertex is at -2, take the opposite, 2. A is 1 again, so it opens up. One more. This time we do have an a value, so we start by separating. So I'm going to look at 2x squared plus 12x, and then we have 17 is on the outside by itself. So I factor out the 2, because I want to make sure that's equal to 1. So we have x squared plus 6x, leave some space, plus 17. Complete the square. 6 over 2 is 3. 3 squared is equal to 9. So I add 9. What did I really add? I added 2 times 9. Because when I distribute this back into that, it's really 2 times 9. So I really added 18. So I'm going to subtract 18. So then this becomes y is equal to 2 times, when this factors, it's x plus 3, the quantity squared, minus 1. So our vertex is at -3 and -1. Again, a few things, always make sure you do the opposite on the outside. So I added 18, so I had to subtract 18 to the outside. And then x plus 3 for the vertex, I had to take the opposite to make sure it's a -3. Okay. So this time I'm going to draw a parabola, and we're going to have to write the equation for it. So I'm going to go ahead and draw this up here. So for the first one, my vertex is at -1, positive 4. And then we also have the point 2, 1. I'm going to go ahead and draw the other one over here. So 3, -2, and 5, 3. There's a point, so I can go the other way. Okay. So you may be thinking, oh my goodness, how am I going to do this? It's not too hard. First off, the vertex is given to us. Okay, so we have a -1 force. That's part of our equation. We have y equals a times x minus h squared plus k. So I have to substitute in, I have y is equal to a times x minus a -1. So it becomes plus 1 squared plus 4. The only piece I'm missing is a. Well, how am I going to find it? I know the point 2, 1 was given to me. So I can plug in 2 and 1 for x and y and find out what is a. So if I plug in 1 for y and 2 for x, I'm going to move across here. So I end up with a times 2 plus 1 is 3, 3 squared is 9, plus 4. So I subtract 4. So I get negative 3 is equal to 9a. When I divide by 9, a is equal to a negative 1/3. So my final equation, y equals negative 1/3 x plus 1, the quantity squared, plus 4. So we're just substituting in the point given, the 2, 1. So if they gave you a parabola, you wouldn't have to draw it or figure out any other points. They gave you the vertex, and they gave you a point. So this is your h and your k, this is x and y. And all you do is plug those into the equation, solve for a, and then plug that back into the standard formula. So again, we have 3, negative 2, and they gave us 5, 3. So here's h, k, x, and y. So I can jump right to the equation. So if we have y is equal to a times x minus h squared plus k, y is 3, we don't know a, x is 5, h is 3, so I'm subtracting it, squared, plus a negative 2. So we have 3 is equal to a times 2 squared minus 2. I'm going to add the 2 to both sides, so I get 5 is equal to 4a. So a is equal to 5 over 4. Now I'm going to leave it as a fraction. So then my equation becomes y equals 5/4 times x. Because x is positive, or the vertex is positive, I'm going to subtract 3, the quantity squared. Now y is negative, so I'm going to subtract 2. And that's my final equation. Alright, so your homework will be on page 290. It'll be 13 through 29 odds. And this will be the only homework for this section, so it's just a one-night assignment. So be sure to have your books and things for class tomorrow to work on that.